Hi guys. A lot of you have asked me to do games development aspects rather than games themselves. So today we're going to focus on the game development basics, and one of the foundational basics is the game's structure or game's architecture, and this is sort of true across many games. And in this video, we'll be mainly focusing on theory, so we won't do much coding. And this is going to be a more theory-based video rather than a practical tutorial. And so everything we cover in this video should be should be applicable to any programming language and any framework that you're using. But as a study or as a case study, we're going to use JavaFX because this channel has been working with JavaFX, so it is a sensible thing to do. Alright, so let's start with the main, as you can see on the screen. So this is basically a JavaFX application which I'm using as a presentation tool. It's actually the first time, so we'll see how that goes. So a program or a game application is essentially a software application, and it has its own entry point. So depending on what language you're working with, so if it's C family language, then you'll have a function called main, and this is the entry point for the application. For scripting languages, you can pretty much call any method, but if you call it main, it's much easier to see where you expect your code execution to start. Alright, as you can see, the arrow, this comes from the operating system. So the operating system will start we'll call the main function within your game, within your program. If it's a Java program, then it will be JVM, Java Virtual Machine, that will invoke the main method. And so once you've started your application, the next thing is to initialize resources, and that would include any dependency libraries, like runtime libraries if we're talking about C++, or subsystems like graphics, audio, input, networking, like whether it's present on the user system. So essentially, this initialize resources stage would be to check the user environment and check that it is ready to run the application, because afterwards you're pretty much initializing game logic, and as a precondition to game logic initialization, that would be that the user environment supports whatever you need to support in the game. For C++, that would be like OpenGL version if we're talking about 3D. Audio, whether it supports 3D positional audio or not, whether the internet is available, and stuff like that. You might also want to check whether the game assets, so basically files that you will be needing for the game, are available on the user system, like the game has been copied completely or installed completely. You might want to check the integrity of files so that none of them have been corrupted when being transferred over network or something. Yeah, so that's pretty much it for the stage. The next stage would be initialize game, which includes things like loading of assets. So in the previous stage, you've just checked that those assets are available, and at this stage you're actually loading the assets. Then you'll have something like setting up the world, the game world. It also depends from one game to another because, for example, certain games will have menus in them. Actually, most games will. And at that stage, you might want to just load the menu and initialize the menu because there might be several like branches out of the menu leading to different game modes like single player, multiplayer, campaign mode or something. And you don't really want to waste your time loading resources that you won't be using. And you can also initialize physics input. So basically all the game will require afterwards or at some point. And certain things can be initialized at runtime, meaning, well, pretty much everything is initialized at runtime, meaning that you don't really need to initialize at this particular stage, like files or textures that are based on certain skills or something like that. So after you've initialized the game, you will then start your main loop, and if you've like searched on the internet about game development or are not sure familiar with game development, at least at the beginner level, then you might have heard about the main loop because this is the essential thing to pretty much any game. And yeah, virtually any game will have a main or the main loop in which everything most of the stuff tend to happen, like the actual game logic, the update, the render, and processing the user input. That we'll talk about it in a minute. So once the game loop completes, then we have a function or a set of functions that will clean up the game and the game environment. So that would destroy objects, C++ style sort of. In Java, you don't really get to control memory management, so certain things are done for you, which is great for the most part of it, but not so great when we get to rendering, because some people would like to have control over render, like what they're rendering and how they're rendering it. And Java isn't that great, although there are libraries that allow you to get to down the graphics card, like OpenGL Access. JOGL, I think, is one of those libraries. And then finally you have release resources. So this basically goes the opposite way. You get you enter the program, you initialize resources, you initialize the game, you run your main game logic, and then when you finish with it, you clean up the game, you release resources, and symmetrically you have exit. So this will return the control to the operating system and sort of close the program. Now if we expand on each of those, so init resources, like we already covered, it will initialize libraries, subsystems. This is not necessarily true for all languages or for all frameworks. For example, in JavaFX, most of the stuff will be done already, like the graphics environment, the loading of native libraries, and yeah, so it's sort of much easier in JavaFX or in Java in general. The game assets, again, this will be different from one game to another, because in Java you could have everything packaged into a single jar file and then make sure that this jar file is not corrupted. You sort of automatically ensure that all of the assets are within the jar file, which is different to C++ approach where you sort of compile everything into an executable file, all the code, and you sort of separate all the resource files and you supply it as an external asset rather than something that is loaded from the same jar file like in Java. You wouldn't package most your assets in an executable file if we're talking about C++. And this also may have an exceptional case with Java if you have like a very large asset, say a 3D model. You wouldn't necessarily put it in a jar file, especially if you're planning to update your application in the future. This might not be a good idea because you'll have to download the whole jar file. Init game will have all of those things. So basically you load game assets, initialize the game world, physics, input. Physics may or may not be present depending on what game we're talking about. Input, this is where you sort of bind your keys to certain actions, or the other way around, actions to keys and to mouse clicks or controllers, joysticks. You also might initialize user interface, sort of create the overlay, position, all of those things, although they might happen using an external file like XML or FXML if it's JavaFX. Once we've done all of those things, we enter the main loop, which is, as the name implies, is a loop. So we go through all of those things every 1/60th of a second to achieve 60 frames per second. But we get to a main loop in a second. So yeah, user input, update, render, synchronization. This is the typical stuff that you will see in most of the games. And although they are placed in sort of this order, it doesn't mean that they will be executed in a single thread, and hence the order might be different, which leads to asynchronous computation. And it is actually important to have certain things done asynchronously. For example, the processing of user input, like handling user input, because the user inputs are delivered from the native operating system event queue, and if we only have one thread, that would mean stopping or freezing the application completely before we can do anything. So again, same thing with update and render. They could be processed concurrently, and most modern frameworks do that. For example, JavaFX, it has its own rendering thread. It's called Prism, and the update happens on the JavaFX application thread, and we'll see that in a second again. So the cleanup game is basically destroy objects if you have the ability to do so, unload assets if necessary, release resources. This would be unloading libraries if you load them, if you load native libraries. Subsystems, sort of release all of the OpenGL surfaces if you use them, and all of the external files, so file system resources. And finally, we exit the application, thus returning the control over back to the operating system. So the next thing to cover would be main loop, and this is one of the most important things in any game really. So the 60 frames per second, you might wonder how it is connected to the main loop. The main loop must run at least 60 frames per second, and basically the number of frames calculated or computed in a single in sort of the main loop will eventually result in the number of frames being rendered, because if you haven't updated the frame, there's kind of no point in rendering. However, if you have a asynchronous render, then you will still be able to render 60 frames per second if you have a powerful GPU, but you might not be able to process those 60 frames per second. So this main loop includes user input, and at this stage we're only capturing user input and not processing it. This is the update, and this is where the processing of user input happens. In fact, update also has lots of other things in it. And render. So this will, if we're rendering it directly to the screen, then you might see some screen tearing, and some of the older games, you can experience that from some of the older games where they draw directly to the screen without using the second buffer, which is, if we are using, then we will have a sync, either function or set of functions that will synchronize whatever you have on the screen with the actual render. It's called buffer. So really it is like a surface which is not visible to the screen. So we need to synchronize contents of the visible surface to the contents of the off-screen buffer. Now the user input may contain all of those or some of those. So keyboard, mouse, and controller, and depending on what kind of input you have. So if we're talking about tablets, then that would be gesture input, so touch listeners possibly. In the update, as you can see, there are quite a lot of things that need to be processed. So we are processing the user input, which we captured in the first phase per se. Physics, if the application supports it. AI, this will be computer behavior, so basically any of the computer controlled players, enemies, and other entities. World, this is sort of like generic update. So it is a game logic that is not part of any of this. So if it doesn't fall into this category of user input physics or AI, it will go as sort of generic game update. Network, if your game is using networking, then this is where you might want to send your updates. Although depending on the application, you might want to buffer your updates first and then send them so that you can get sort of higher throughput, or rather more efficient throughput. User interface also needs to update with the everything that happens in the world. So for example, if you've been hit by an enemy, your health bar will go down a little bit, and this needs to be updated on the UI because you typically have two types of variables, one for the model and one for the user interface. And in JavaFX it's actually done very efficiently because you can bind one property to another. So properties and bindings really help in that case. With render, it's pretty much just render game and render UI, although render game will have lots of other sub-functions like pre-render, post-render, if we're talking about real game engines. in JavaFX, you pretty much don't get to use any of those. You only specify how things should be rendered by placing them in scene graph, and that scene graph will be rendered off the screen, and every 1/60th of a second there will be a pulse event on the glass windowing toolkit thread, which is same as the JavaFX application thread, and this is where the synchronization happens. So the JavaFX scene graph, or the objects within it, will be synchronized with the render off-screen render sort of surface. So you get to see the updated version of the screen. And this is actually done using high resolution timers, native timers. And this is why you get a much better synchronization with the actual operating system synchronization of the view of the screen. So what else there is to cover? Right, we should move to the example that I've prepared, which is essentially the main loop and certain functions outside the main loop which correspond to what I've been talking about. So this is the very simplistic JavaFX application on the left. You have an example app, which is the class name, which extends JavaFX application. And there are a few methods that you override. So init, that is the place you might initialize resources, although you need to make sure that you don't call certain JavaFX methods, because all of the changes to UI must happen on the JavaFX application thread, and this init method will not be executed on it. In fact, this goes like this. So when you start the application, the main method gets called. Then you call launch, which launches actually doesn't launch the JavaFX application directly. It creates a new thread called JavaFX launcher, on which you then launch the actual JavaFX application. And this init method will get called on that JavaFX launcher method, and not the application thread. Launch thread, sorry. After the init method completes, the start method gets called, and if you've followed any of the tutorials on this channel, then you are already familiar with the flow of the JavaFX start method. You show the application, you pretty much configure the application and then show it. I will not run the application, it's just there to give you a sense of mapping of what the game architecture looks like and what you do with or how you do it in JavaFX. Also, this animation timer is the thing that will be executed every 60th of a second, so giving us 60 frames per second effectively. Although I've put those things in there, they don't really matter, because user input gets asynchronously captured by the native event system and gets wrapped with a JavaFX event and gets sort of passed to you for a callback process. So if you specify a callback like set on mouse clicked, and then you pass a method which should be executed on this event, then it will be executed. So this pretty much has nothing to do with it. I simply put it there to give you a sense of sort of similarity. Render, again, is executed on the Prism render thread. So we don't get to control it. And it happens right after all of the handle method all of the contents of the handle method will be completed. Synchronization is again done automatically, so there is no need to worry about that. As you can see, the JavaFX platform really makes it easy to develop games applications or some basic games applications. And the only thing you need to worry about is essentially the update. And this is where you will be calling the update. And so effectively this is the main loop of your game. And irrespective of the complexity of the game, you will have some sort of main loop in the game. Whether it's 2D or 3D, it doesn't really matter. Then we have a stop method that is also overridden and will be called just before the application exits or JavaFX platform will exit. And this is where you can release resources. I believe this is called on JavaFX application thread. Yeah, it is. So you can you can do pretty much anything you want. And this pretty much sums it up, the whole, or at least the basic game development or game architecture. And in the future tutorials, or actually we've already covered examples of doing games on JavaFX platform. So in the future we might do something else, like going deeper into the main loop and maybe asset management or something like that. And thank you for subscribing and suggesting what topics for me to cover in the future tutorials. And also thanks for staying for the whole video.